Number 7. If f of x equals 2x minus 12, what is f composition f inverse of 10.5 equal? Well, remember, or you should, remember that when you find the composite of f and an f inverse, it's always supposed to equal x. And in reverse, the same thing. F inverse composite f should equal x. That's how we verified that two functions were inverses. Well, in this case, they want f composition f inverse of 10.5. Well, I missed a piece, but it's not really part of the big picture. But I'll write it. Maybe it'll make some sense. So it's f composition f inverse of x, right? And x goes in both places, and it equals x. So with that being said, if you were to mirror that with the current problem on our hands, f composition f inverse of 10.5, we're telling you that 10.5 takes the place of x. So if f composition f inverse of x equals x, that means f composition f inverse of 10.5 is going to equal 10.5. So it is made to be a simple problem, but if you don't make that connection right away, then the problem ends up going to be a lot more work for you. So try and remember this, please. So f composition f inverse of x is equal to x. F inverse composition of f of x is also equal to x. So it doesn't matter the order. If you take the original and the inverse with the composite sign between, you're always going to get x back. Always. That's proof that it's a inverse. So it shouldn't involve any more thought than that. But again, you're going to have to remember this on your own. For number 8, we're going to state whether the two equations are inverses or not. So we're going to have to validate or prove this. So we're going to first find f composition g of x on the left-hand side. So that means f is my candy shell. So write it out, 6x plus 4. Now let's get our parentheses ready to substitute in the gum function, which is g. So that's 6x minus 4. Bring down my plus 4 from my candy outer shell. And now let's simplify. So we would distribute the 6 into the parentheses to get 36x minus 24. And then bring down the plus 4. So that would leave me with 36x minus 20. Is that x just by itself? Absolutely not. So the left-hand side are not inverses. Now let's talk about the right-hand side. So we're going to do M composition N first. So M represents the outer shell, so 3x plus 9. Now let's get the outer shell ready for its gum function. So gum is n, so that's x minus 9 over 3. And then bring down the plus 9. Now we distribute the 3 into the parentheses. It's technically 3 over 1 because you're multiplying it with a rational function, aka fraction. So when I multiply, it ends up being 3 times x minus 9 over 3. And then still the plus 9 is coming. Again, well, no, never mind. I have 3 over 3, right? So they will cancel each other out, and I'm left with x minus 9 and then plus 9. X minus 9 plus 9 is simply x. So far, that situation checks out. Now let's check out in composition M. We got to make sure they both work. So now n is the outer shell. So x minus 9 over 3. Now let's get it ready to substitute our gum function, which is 3x plus 9, then minus 9 all over 3. Now let's simplify it. So I have 3x plus 9, then minus 9. So that would give me 3x at the top. Then I have 3x divided by 3. My 3's cancel and leave me with x. So it checks out. So since both of them equal x, both ways, mon and nom, these are inverses. But you have to check both first to be sure. All right, we're going to solve these systems that have 3 variables. So we need our handy dandy calculator and matrices. We're going to use the augmented matrix. So let's set up the first row of our matrix. So that's negative 9, 3, negative 2. Draw our line for equals, and then 61. Second row is 8, 7, 5, and negative 138. And last row is 5, negative 5, 8, negative 45. Let's do number 10's augmented matrix at the same time. So that way I can pick up the calculator and do it once. So that would be 3, 6, negative 2, draw my line, negative 6. 2, 1, 4, 19, negative 5, negative 2, 8, and 62. Now we can grab our calculator. Second quit will take you back to the basic calculator screen. Don't hit reset all the time, folks. Trust me. So now to get RF, I hit second matrix, math, alpha, apps. All right. Now hit alpha zoom. And both of these matrices have 3 rows. So change it from 2 to 3 by hitting enter. Oops. There we go. And 4 columns. Now go to OK. Okay, so -9, 3, -2, 61, 8, 7, 5, -1, 38, 5, -5, 8, -45. Double check to make sure we've entered everything properly, all the correct signs, and now hit enter. So the output reads 1, 0, 0, -8, 0, 1, 0, -7, 0, 0, 1, -5. So if we go back to the problem, it was an A, B, C order for all equations. So that means our output, this is A, this is B, this is C. So we write it as an order triple, it would be -8, -7, -5 in alphabetical order. Now, if I don't want to type or go through all the keystrokes again, because I know I'm going to use the same size matrix, just highlight the matrix and RF, it'll copy it down to the current line. Now we just have to change all the elements. Just be careful. I would hit clear and then retype. Okay, -2 can stay. And then I need a -61, a 2, 1, 4. I'm going to clear this one because the next number, the new number doesn't take as many characters. I need a -5, a -2, an 8. I'm going to clear this one, and a 62. All right, double check to make sure everything matches up. No, it doesn't because it's a -6 on that top, not -61. So delete that one. Now get out of there. Now we're good. Yes, so hit enter. So this output says 1, 0, 0, -4, 0, 1, 0, 3, and 0, 0, 1, 6. So when I go back to the problem, it was in X, Y, Z order. So that means this represents X, this represents Y, this represents Z. So as an order triple, it would say -4, 3, 6. Make sure you put them in alphabetical order. 11, write the system of equations needed to model this situation. At a competition involving multiple schools, one school earned 14 points with first place finish. Second place finish, two second earned, okay, let's rewind. One school earned 14 points with one first place, two second place finishes, and three third place finishes. Another school earned 18 points with 2 first place finishes, 2 second place finishes, 2 third place finishes. Another school earned 16 points with 3 first place finishes, 1 third place finish. How many points is each finish worth? Alrighty. So there's 3 schools. So each equation would represent one school. So the first school earned 14 points for 1, 2, and 3. So let's first establish some variables. So let's say F is first place points. Let's say S is second place points. And that means T is third place points. Because that's what we're going to find. It's asking for how many points. So we don't know that right now. So again, the first equation is school number 1. So they had 1 first place plus 2 second place plus 3 third places, and they scored a total of 14 points. The second school earned 18 points for 2 first places, 2 second, 2 third. Okay? So the second school, 2F plus 2S plus 2T equals 18. And now the third school had 16 points for 3 firsts and 1 third. So the third school, 3 first places, so 3F plus 1T, and they scored 16 points total. So those would be the 3 equations for this system. Now if I were to solve it, let's set up a matrix, an augmented matrix. So the first row would be 1, 2, 3, 14. Second one would be 2, 2, 2, 18. And the third one would be 3. And notice I skipped space because they didn't have any second places. So we got to put a 0 for second place of that third school, and then a 1, and then 16. I did that on purpose so that you could see clearly that something was missing. So whenever something's missing, you have to put a placeholder. Now we can grab our calculator. This also has 3 rows, 4 columns, so I can copy and paste it down without going through all the keystrokes. All right, so this becomes 1, this becomes 2, delete in 3, then this is 14, then that 2 is fine. We need another 2, another 2, change that 9 to an 8. We need to delete the negative, and put 0, 1, and then 16. Everything looks good. Hit enter. All right, our output is 1, 0, 0, 5, 0, 1, 0, 3, 0, 0, 1, 1. So again, it maintains its order. So first, second, third. So that means this is first, this is second, this is third. So in other words, first place is equal to 5 points. Second place is equal to 3 points. And third place is equal to 1 point. So that's how you would interpret this situation using matrices and systems. Write a system of equations needed to model this situation. At a festival, Dennis bought 1 hot dog, 1 burger, and 1 drink for $10.50. Mitch bought 2 hot dogs, 2 burgers, and 1 drink for $17.50. Robert bought 3 burgers, 2 drinks, and $19. How much did each item cost? So we have 3 people. There's going to be 3 equations, but we need our variables first. So we need a variable for a hot dog. So let's go with H. That's the hot dog cost. We need one for a burger. So B for burger cost. And then we need D for our drink cost. All right, so again, this scenario is similar to the last one. Each person will be an equation. So the first person was Dennis. 1 hot dog, 1 burger, 1 drink. So for Dennis, 1H plus 1B plus 1D was equal to $10.50. For Mitch, 2 hot dogs, 2 burgers, 1 drink, $17.50. So 2H plus 2B plus 1 drink was $17.50. And last for Robert, 3 burgers, 2 drinks, $19. So 3 burgers, 2 drinks was $19. So those are our 3 equations. Now we can write our matrix. So the first row is 1, 1, 1, 10.50. Second one is 2, 2, 1, 17.50. And again, we're missing something in our third equation, so we're going to put a 0 in its place, then 3, then 2, and then 19. Now grab our calculator. Again, it has 3 rows, 4 columns, so copy, paste. All right, that first one can stay. This becomes a 2, a 1, a 1. Then we need 10.5, 50, 2, 2, 1, and then 17.50. We need a 0, 3, 2, and 19. Since they're all dollars and cents, I'm just keeping it consistent. Could I had only written just 19? Yes, but just trying to keep it consistent. Alrighty, now here's my outcome. So 1, 0, 0, 3, 0, 1, 0, 4, 0, 0, 1, 3.5. Okay, so with that being said, we kept them in the same order every time we wrote our equation, H, B, D, H, B, D. So that means this is H, this is B, this is D. So what that means is a hot dog is equal to $3. A burger is equal to $4. And a drink is equal to $3.50. So that's how you make the numbers make sense and have some value and meaning behind them. Let's pause here and resume in just a moment.